Okay, so I want to go over how the angles relate in a rectangle. First things first, when you have a rectangle, you should know that by all the rules that are given in your flowchart, your diagonals are congruent to each other because they're a rectangle. And then because a rectangle is also a parallelogram, they bisect each other where they cross. So this diagonal cuts this one in half, this diagonal will cut that one in half. What that results in, all of these half diagonals are the same value. They're all the same length. So what ends up happening, you end up having isosceles triangles all the way around. You have this isosceles triangle that is a vertical pair with this isosceles triangle. Those are congruent to each other, exactly congruent. Same thing here. These two, you've got congruent isosceles triangles. Okay, the way that's going to help us, if I have any one angle given to me, I can figure out all the rest of them just based on my rules of isosceles triangles and my rules of rectangles and such. So if this is 60 degrees, let's say that's 60 degrees. Well, I know by this being an isosceles triangle, then this is also going to be 60 degrees because they're going to be the same angle. That's a crappy looking 60. So I got two 60-degree angles. Well then, if this triangle is the same as that triangle, heck, I can fill in these 60 degrees over here as well. They're all the same. I can use triangle sum to say, hey, I know what this angle is going to be. Because 60 and 60, right? If those are each 60, then what ends up happening here, I actually made a equilateral triangle, not really paying attention to it. But now this is not 60 because these two are. It just so happens these two make 120, and to make 180, I got to have 60. So you'll see that on these ones. This will not be 60 and 60. Those will be 120. But anyway, so I have isosceles triangle here and isosceles triangle there. Those match up to each other. All right, so if I'm trying to find this triangle, these triangles here, I can say, okay, well, on the edges, I know I got 90-degree angles. And I can do it a couple of different ways. I could have found this angle first and then found these two. But I know on the edges, I got 90-degree angles. So if that's 60, I've got a 30-degree angle here, 30-degree angle there, because that's what it takes to make all those angles 90. It's 30 degrees added onto the 60. Now with those, triangle sum, right? I can use this is triangle sum to make that this is 120, or I could say that's a linear pair to make it 120. Either way, as long as I know a way to get to the 120 degrees right there, then it doesn't really matter how I do it. And I just fill in all those angles just based on my rules and based on that being already 60 degrees. All right, real quick with the rhombus. I've got this is a rhombus. Things we know about a rhombus. Whatever one side they all are. So these sides are all congruent to each other, right? Whole point of being a rhombus. You get the rules of the regular parallelograms, and then you get special rhombus rules, such as the diagonals are perpendicular. They make 90-degree angles all the way around. Other thing we know about the angles, the diagonals, so these diagonals will bisect opposite angles. So it means that this diagonal will cut this angle in half, and it'll cut this angle in half. Where that helps us, I can go ahead and I can say, okay, well, let's say that this is 50 degrees. Well, if that angle is 50 degrees, then I know this angle is 50 degrees because they got cut in half. Well, since it's parallelogram, opposite angles are also congruent to each other. So if that's 50 degrees, these are all 50 degrees. So this angle being 50 degrees told me that that's 50 degrees, and these two are also 50 degrees. All right. And parallelograms, I know that consecutive angles are supplementary. So if these add up to 100 degrees, so if this whole angle is 100 degrees, this whole angle has to be 80 degrees. So I end up having 40 degrees here, 40 degrees there. I could have also done this another way. I could have said, okay, I could have found out those are 40 degrees by saying, well, if these are perpendicular, then I've got 90-degree angles all the way around. 50 and 90, use triangle sum and say, well, 180 minus 50 minus 90 will give me 40. Doesn't matter. As long as you understand these rules, rhombuses are really easy. Angles of a square are super easy. They're always the same thing. They never change. Square is a rhombus. So square being a rhombus says that the diagonals are perpendicular to each other. Also, with it being a rhombus, the diagonals bisect opposite angles. So these two angles will be the same. These two will be the same as each other. These are the same as each other, and these are the same as each other. Well, a square is also a rectangle. So this angle is 90 degrees. That angle is 90. I got 90 degrees all the way around. So what happens, the angles are exactly the same for every single square. I have 45-degree angles created by my diagonals all the way around. That's the only possible way that I could have 90 degrees all the way around and still follow all the rules of rhombus and follow the rules of my rectangles. That's it. That's all you have to know for angles in a square. Now, there's other parts of squares you don't need to know. You need to recognize that these are going to create right triangles. So if I had a side here and a side there and I wanted to find this side, I could use Pythagorean theorem. Other things with a square, just like a rhombus. Let's say AD is 5. Well, then that's 5, that's 5, that's 5, right? Just like a rectangle, every little half diagonal is the same length because the diagonals are congruent and they bisect each other. So whatever this value is from A to E, E to D would be the same, E to C is the same, E to B is the same. Squares are real simple, okay? And I forgot to write that this is a square, but hey, it's a square. No big deal.